Welcome back to All This Math. This is Professor Parker. Please make sure you're already subscribed to the All This Math YouTube channel. Like this video. Go ahead and hit the button. Like the video. All right. Drop a comment down below, especially if there's something that you don't understand about what I end up explaining on this geometry problem that we're about to get into. All right. And also share the video. Last but not least, share the video. And I also want to shout out these 4 women that are on my chest, on the face of this t-shirt. We got Harriet Tubman right here. We got Rosa Parks right here. We got Angela Davis right here. And we got Asada Shakur. Asada Shakur, who also is prominently displayed right here. And also my daughter Asada, who you've seen on this channel as well, is also named after Asada Shakur. All right, now, what are we doing today? Today, we're going to do some algebra mixed with some geometry. All right, or I should say some geometry that utilizes algebra. What I tell students all the time is geometry is just algebra with shapes. That's pretty much all it is. So here we have a line, all right, and we have 2 lines right here. Now, these lines are parallel lines. Now, how do I know that they're parallel lines? I know they're parallel lines because on the line, I have these 2 arrowheads, one arrowhead and one arrowhead written within the line, right? Not at the end of the line, not at the ends, right? Like these arrowheads, but in the line. That means that line M and line R are parallel to each other. All right. That means that every corresponding point between this line and this line, right, are equidistant. They're the same distance. All right. So this point to that point is just as far away as this point to that point, and so on and so forth, forever and ever. Because lines go on infinitely to the left and infinitely to the right, meaning these lines will never intersect each other. They will never intersect each other. And it will also be just as far away forever. All right. Now, these lines are parallel. When a line cuts through 2 parallel lines, we call that a transversal. Transversal. Write that down in your notes. Transversal. Rewind the video if you need to spell it, need the spelling again. All right. Transversal. A transversal cuts through 2 lines. In this case, the lines happen to be parallel. So when a transversal cuts through 2 lines that are parallel, it creates angles, right? It creates angles. And then there are special relationships between those angles. All right. It might create corresponding angles. It might create alternate interior angles. It might create alternate exterior angles. It might create consecutive interior angles, which textbooks back in my day, 30 years ago, when I was taking geometry in the 9th grade in Mr. Bessick's class at Poly down in Baltimore, we call them same side interior angles, right? I don't know if textbooks call them that these days. These days, I only see them described as consecutive interior, which is just synonymous. Again, math is a language. Geometry is a language. You got to know the language, all right? You also have to know the synonyms, right? You got to know when something is the same thing as something else, or something that we used to call it back in the day. They call it something different today. So back in the day, it was same side interior angles. Today, consecutive interior angles. All right. Now, what you want to do when you see a problem like this, because you're trying to solve for x, and you see the variable x right there, we want to know what number this x represents. All right. And what number this x represents, because these are the same variable. All right. So first you want to look at the relationship between the angles. This is an angle and this is an angle. Now, when you have angles that are on the same side of the transversal, right, and also in relation to their own parallel line in the same way, again, in relation to their own parallel line in the same way, meaning this angle is above its parallel line. This angle is above its parallel line. So when 2 angles got the same relationship to their respective parallel lines, and they on the same side of the transversal, we call those corresponding angles. Corresponding angles. I'm going to write that down. Corresponding angles. Corresponding angles. So again, when you got angles that are on the same side of the transversal, not alternate sides, but the same side of the transversal, this angle is to the right of the transversal. This angle is to the right of the transversal. They're on the same side of the transversal, like being on the same side of the street. All right. And also, when you look at the parallel lines, right, because the angles are formed with the transversal and the parallel line. So if the angle is above this parallel line and the other angle is also above this parallel line, that means that they're both above the parallel lines. they're both above their own parallel line, right? That means the angles are corresponding. They're corresponding angles. Now, once you know that, then you think about, well, what's the relationship between corresponding angles? This is something for you to memorize. Corresponding angles are congruent. They're congruent, meaning their measurements are the same. That means that this angle is equal to this angle. This angle is equal to this angle. Now, that means with that information, I can create an equation and then solve for x. So I could say that x is equal to 3x plus 15. So now, once I write the equation, the geometry is done, pretty much. Now I'm just using algebra. I'm solving an equation. I'm solving for x. So those of y'all watching this, you need to know how to solve linear equations. And this is a linear equation because the biggest exponent that you don't see is a 1. This is x to the first power. This is x to the first power. Ain't no x to the second, no x to the third. I got a whole playlist on this channel on solving linear equations. Go in, go down the rabbit hole. It's like 30 or 40 videos on there. Go check it out. All right, now, but there are a few ways we could do this. I'm trying to solve for x, so I'm going to isolate x by itself on one side of the equation. But you have to be careful. When you have equations where their variables are in more than one place, we got to combine the variables. All right? So I want all my x's on the left-hand side. So what that means, I'm going to get rid of this 3x from the right-hand side. So I need to do the opposite operation. 3x means positive 3x. The opposite of a positive 3x is a negative 3x. The operation would be subtraction. So that means I'm going to do minus 3x on the right-hand side, and I'm going to also do minus 3x on the left-hand side. 3x minus 3x is 0. X minus 3x. We got to know how to do subtraction with negative numbers. All right? X minus 3x, think about the coefficients. 1x minus 3x. Excuse me. 1x minus 3x, we're dealing with 1 minus 3. 1 minus 3. Think about it in terms of a number line. You start at 1 on the number line. Minus means you move to the left. You go 3 spaces because you subtracted 3. Start at 1, move to the left, 3 spaces. Start at 1, move to the left, 3 spaces. That's what 1 minus 3 means. Where you end up at is your answer or your difference. 1 minus 3 is negative 2 because you would end up at negative 2. So this is going to be negative 2x is equal to 15, right? Negative 2x is equal to 15. We did the minus 3x and a minus 3x, right? Negative 2x is equal to 15. Now, I'm trying to solve for x. I need to get rid of this negative 2. Now, negative 2x means negative 2 times x. That's multiplication. What's the opposite of multiplication? Division. We do opposite operations to get rid of things in algebra. So that means I'm going to divide by the same exact number. I'm not dividing by a positive 2. I'm dividing by the same exact number, negative 2. Also, we're going to be balanced, just like how we subtracted 3x on the right and 3x and subtracted 3x on the left. We're going to do the same thing over here. Negative 2 divided by negative 2 gives us positive 1, leaving us with positive 1x. You got to know the language of math. Positive 1x and x mean the same thing. Positive 1x and x mean the same thing. So now we got x right here. These cancel out. Now, 15 divided by negative 2. What's a positive divided by negative? It's going to be a negative. Whatever the answer is, it's going to be negative. 15 divided by 2 is 7.5. 7.5. So x is going to equal negative 7.5. Something else I forgot to mention. You got M, R, and D. That's like Martin R. Delaney or Martin Robeson Delaney. Somebody else you need to research if you're not that familiar with him, right? Brother from the 19th century, right? Was a barber, went to medical school at Harvard, but they kicked him out because the white people at Harvard were uncomfortable, right? Having to compete with a black man that was smart, just as smart or smarter than they were, right? Also served in the Union Army, wrote several books. Martin Robeson Delaney. Martin Robeson Delaney. Look him up. Martin R. Delaney. Martin R. Delaney. Martin R. Delaney, a contemporary of Frederick Douglass. You might have heard of Frederick Douglass. If you heard of Frederick Douglass, you should know about Martin R. Delaney. All right, keep that in mind. All right, so we got x equals negative 7.5. This is the solution to our equation. Now, we can prove that this is true, right? Because these angles, since they're corresponding angles, should be congruent to each other. So this should be, let's see, if that's going to be negative 7.5, then this should be negative 7.5, right? But you know what? When I copied this problem down, this was not, oh, you know what? I mean, the math is right, but I ain't write the problem correctly. You know what? Yeah, the math is right, but I ain't write the problem correctly. It should have been 4x. This should have been a 4x, right? I ain't copy it properly. But the math is still solid, though. All right, the math is still solid, even though in reality, we wouldn't have a negative 7.5 degree angle right here, right? But as long as we still get negative 7.5, that's proof that the math is solid. Because look, what's 3 times negative 7.5? Let's do some mental math. 3 times negative 7.5, 3 times negative 7 is negative 21. 3 times 0.5 is negative 1.5. Negative 21 minus 1.5 is negative 22.5. What's negative 22.5 plus 15? Negative 22.5 plus 15 is also negative 7.5. So look, this is the same as that. So this angle is congruent to that. And they are corresponding angles. So even though I copied the problem wrong, I knew it looked weird when I was doing it up here on the board. I'm like, yo, I'm not supposed to be getting negative 7.5. That ain't what I got when I did it on paper, right? But anyway, the math is solid, right? It's just that in reality, if this were a more realistic problem as opposed to being a theoretical problem, we wouldn't have a negative 7.5. But the math is still solid because they match up. So that's proof that the answer is correct. All right. So that being said, make sure you are subscribed to the channel. Make sure you like this video. Make sure you drop comments down below or questions, comments or questions down in the comment section. All right. Also share this video with whoever. Again, HSPT Math, high school placement test for 8th graders that are attending Catholic schools or other parochial schools to find out where they were placed in a math class in 9th grade. All right. That's what this is an example of. This is an example of one of the problems that you might see, and also you might see this in any geometry class, right? This is a typical question you'll see in geometry dealing with transversals and parallel lines, corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and so on and so forth. Vertical angles too. Throw those in the mix also. All right. I will see you on the next video. Don't forget, Martin R. Delaney, Rosa Parks, Harriet Tubman, Angela Davis, Asada Shakur. Peace.